Hello, good morning everyone. Boys and girls of grade 8, I wish this video finds you well. We will take today lesson 5-1, which is about estimate solutions by inspection. Now I want you to take a moment and think, what is our objective? This is the session for Sunday, 22nd March 2020. Before we start with the lesson, I need to go through the structure of the lesson of today. Today we will start with the introduction or a starter for previous learned skill. Then we are going to go into the core by watching a video and answering some questions through the video in order to check your understanding. Then we are going to solve some questions as assessment for learning, differentiation, and according to that, we are going to go after that to Mastery Connect as a plenary. What are the resources needed? You know, Volume 1, Pearson book. And if you don't have the book, no worries at all. I will upload all the PDFs used in this lesson on your Google Classroom, so you can follow. Be aware that this Mastery Connect can be taken as your classwork mark, so please think and try to understand and ask me if you have any question during the lesson. Now I want you to take a moment and guess what can our objective be. So you should at the end of this lesson to know how to find the number of solutions of a system of equations by inspecting these equations. So you will take a look of the system of the equations and then you will decide, does it have infinitely many solutions, one solution, or no solution at all?
So if you can remember that we've taken a lesson about the infinitely many solutions, no solution, or one solution, but it was for one equation. Now we are going to take it for a system of equations, but let's remember together how we are solving it step by step. The first one here is telling you 4 multiply 3x plus 2 equals 4 multiply 2x plus 3 plus 4x. Now, if we're going to solve it, you know already that we need to work it sign times sign, number times number, and variable times variable. The sign here is positive. I know it's positive because it's not there. If it's not written, it's positive. And also, if no number there, I know it's 1. It's called the invisible math numbers or the invisible math terms. So positive multiply positive is going to give me positive. 4 multiply 3, 12. And nothing here, which means 1 as a variable, multiply x. What's 1 multiply x? X. Then positive multiply positive, positive. 4 multiply 2 is 8. And the variable 1 with the variable 1, it's already 1. I will not write it there. This is the left-hand side. Let's take a look of the right-hand side. Positive times positive, positive. 4 times 2 is 8. 1 times x is x. Then positive times positive, also positive. 4 times 3 is going to give me a 12. And here I have plus 4x separately. In this term, or in this side, I can work it further. I can, because I have like terms, which are 8x and 4x. 8x plus 4x was gonna give me 12x, and the positive 12 as it is, this is gonna be my right-hand side. I reached 12x plus 8 equals 12x plus 12. Now the second step, as you remember, we need to move all the x's in one side and all the numbers in the other side in order to isolate the x. So I'll have here the 12x as it is. I'll move the 12x from the other side here with a different sign. It's going to be minus 12x. And the positive 8 is going to move to that side with a different sign, plus 12. 12x minus 12x is going to be 0. Negative 8 plus 12 is going to be 4. Now, I know already that 0 is not equal to 4. So that's a wrong conclusion. Now I know I will have no solution because it's already a wrong conclusion from the equation. So if I have, this is a rule for yourself, if I have two parts of equation that they are not equal, I will have no solution. Now let's take a look at the second example. The second example is telling you 10 multiply x plus 4 minus 3 equals 14x plus 1. Imagine the right-hand side. The right-hand side is already simplified. I cannot simplify it more. But in the left-hand side, I can multiply. 10 times x is going to be 10x. 10 multiply 4 is going to be 40 minus 3. Then I have these like terms. Positive 40 minus 3 is going to be positive 37. Now let's move the x's in one side and the numbers in the other side. 10x minus 40x equals negative 37 plus 1. So negative 4x equals negative 36. Divide both on negative 4 in order to isolate the x. So x is going to be 36 divided 4 is going to be 9. Now I have one value of x. Because x equals 9, I have one solution. So if you reach out that x equals something, you know this is the one solution of x. The last one is going to be 2 multiply 10x plus 15 minus 10 equals 15x plus 20. The right-hand side is already simplified. And the left-hand side, let's check it together. 2 multiply 10x is going to be 20x plus 2 multiply 15, 30 minus 10, which is going to be 20x. And here we have also plus 5x. Sorry about that. Now 20x plus 30 minus 10 is going to be plus 20. The other side, 15x and 5x are going to give me 20x plus 20. If you notice here, this right-hand side is exactly like the left-hand side. If we have them the same, they are equal to each other, I would know that I have infinitely many solutions. So the rule number 3 about these issues that if I have something equal to something, exactly equal, so I'll have many solutions for this equation.
How can you determine the number of solutions of a system of linear equations? Think about this question during the lesson. Deanna drew the 3 pairs of lines below. Each pair represents a system of linear equations. A system of linear equations is formed by 2 or more linear equations that use the same variables. How can you use the graphs to determine the number of solutions of each system?
A solution of a system of linear equations is any ordered pair that makes all equations in the system true. The equations of the first linear system have different slopes. The lines on this graph intersect at only one point. The system has one solution, the ordered pair. 1, 5, or x equals 1 and y equals 5. The equations of the second linear system have the same slopes and different y-intercepts. The lines do not intersect and never will. They are parallel lines, so this system has no solution.
The equations of the third linear system have the same slopes and the same y-intercepts. The lines intersect at every point. They're equivalent equations, so they are the same line. This system has infinitely many solutions. Comparing the equations in a linear system can show you whether the system has 0, 1, or infinitely many solutions. When equations in a linear system have different slopes, the system has one solution. When a linear system describes parallel lines, the system has no solution. When a linear system describes the same line, the system has infinitely many solutions. How do the points of intersection of the graphed lines relate to the solutions of the systems of linear equations?
Well, good morning everyone. I hope you are feeling well. Now, we are going to ask you to open the book on page 261 because this is how we are going to start practicing our questions on the book. If you don't have the book, no problem at all. I'll put for you a PDF for all the pages that's requested on Google Classroom. Now I need you to take a look of question 7, the level practice, in the book in page 261, as we said. If you want to check what does it mean by rovers, you can check by Google. Rovers is this robot that they are sending for other planets in order not to get risk of any astronauts in order to explore that planet. They are going to explore the system, the weather, basically everything on that planet. This, you can Google them, and you can also reinforce your memory for Hazan Mansouri. They send him in this risky task, but they cannot send every single time someone to risk his life. We can send a robot. He can do the task, or he can do a little bit less than the task with no risk. Basically everything on that planet with no risk at all. Now let's go back to our question. You have two equations for two rovers on that planet. The system of equations, as we know, you have to find out the same variables in each equation. The first equation, the variables are x and y, and you know it. In the second equation also, the variables are x and y. So yes, it's a system of equations. Now let's go back to our question. You have two equations for two rovers on that planet. The system of equations, as we know, you have to find out the same variables in each equation. The first equation, the variables are x and y, and you know it. In the second equation also, the variables are x and y. So yes, it's a system of equations. We can find out how many solutions we have in these two equations by two ways. First way, we can draw them and see how can they intersect on each other, and the number of the points of the intersection is going to be the number of the solutions. Or we can find another way. So let's solve it the first way first. We can find out how many solutions we have in these two equations by two ways. First way, we can draw them and see how can they intersect on each other, and the number of the points of the intersection is going to be the number of the solutions. Or we can find another way. So let's solve it the first way first. We can find out how many solutions we have in these two equations by two. So if we graph the first equation, which is going to be y equals 1.9x minus 8, and the second one is going to be 7y equals 13.3x minus 56, I'll find that they are exactly making one line. So they are exactly above each other. So basically, it's infinitely many solutions. Infinitely many solutions. The other way we need to explain. Now, if we put the two equations beside each other, and then we are going to put them in our form that we know. Do you remember it? Yes. Y equals slope x plus b. Now, if we solve the second equation to make it this standard form, you will find that 13.3 divided 7 is the other 1.9. In this case, do you notice something? We will have the slope of rho over A equation is going to be the same as the slope of rho over B equation. And that's, my dears, are going to be the answer of the first sentence. What do you notice about the y-intercept from the two equations? Yes, if I divide the negative 56 divided 7, I'm going to have negative 8. So I will have the same equal y-intercepts in both of them. So if I have the same or the same slope, same y-intercept, it's gonna give me infinitely many solutions. So either you use the first way that you graph both of them, or else the second way, which you compare the slopes and the y-intercepts, you can know that it's infinitely many solutions for both of these systems. So either you use the first way that you graph both of them. What does it mean, infinitely many solutions between both of them? What do you think? For the rho over A and the rho over B, give me your answers on the comments.